Greetings everyone. I now have my low noise amplifier ready for 10 GHz receive, very low noise figure and a good amount of gain. How did I proceed? It's a recovery job again. I used this LNBF, the donor for the horn. This is a 11 to 12 GHz DSS dish network. It was for the Bell Express View network. Decided to open it up and I did cut off an area of the PCB. How did I proceed to figure out where to cut? Well, here's the board that I recovered, and here's the large board. I essentially looked at where the bias circuit was, and this is the chip that's here. This is used to produce the negative gate voltages for the two FETs that are here. And I looked where this thing was, how it was fed, what voltage it was fed with, and it's plus 6 volts. There was a regulator for that at the other end of the board. It was right here. And on my first system, the one I built for portable operation in 2024, I kept the whole board, the two strips, because there are two channels on this thing. And I kept the whole thing, but it creates a large PCB for no real reason. The only thing we really need is this corner. So I looked, as I said, I looked at first stage RF, second stage RF, and then where can I cut? If I extract here at the end of the second stage, I can certainly cut here and then disconnect the following channels. And then here was just ground all the way. The DRO, the LO, which I tore off and cut right across here and could detach. And then the probe here, of course, I cut it off. It was right here and I decided to remove it. Now you can see much clearer what I've kept. The bias circuit here, and this is the RF strip with the input right here, first stage, second stage, and then I recover here. It used to go to a filter, but I peeled off the track. I just left a bit of track here to solder a connector. I'll show you the two connectors in a minute. And this is the input here with another SMA connector. I drilled a very small hole. It was actually a 0.65 millimeter hole. Two places, just large enough to fit the small pin of the SMA connector. And I've added this piece. If you notice here, this is the input, but there's a piece of track here that ends nowhere. This is ground here. This is for tuning reasons. I looked at the VSWR using a directional coupler, the same technique I used in the previous series of videos, and noticed that it was not very good. I had only a 5 or 6 dB of return loss, not good enough. So trial and error, I brought in a piece of tin plated copper foil and I just soldered it in place, moved it around, peeled it up, down, while looking at the VSWR, and then found that the best position and length was like this. And with this tuning, I have more than 20 dB of return loss, which is basically 1.1 to 1 of VSWR. That's for the input. The output, I added this capacitor right here. This guy here, I added a cap, which I recovered from the other board, the larger part, recovered a coupling cap. The capacitor that was here on the other channel, recovered it and installed it right here. I first cut the track, of course. So now I am AC coupled on the output. I am still DC coupled on the input. It goes straight to the connector without any capacitor. But that's okay because this thing is going to be connected to the horn antenna and the probe is just floating inside the horn. So it will be DC floating. And that's important because there is a minus 0.5 volt supply brought in for the gate here to bias the transistor through that very thin trace coming from the top here, minus 0.5, and same thing for the second stage, minus 0.4, 0.5 roughly. And this biases the transistor to about 12 milliamps, 10 to 12 milliamps. So that's the drain to source, source being ground, and same for the two. So these two biasing circuits I didn't touch. I just recovered the chip, made sure the traces and everything were included to bias the two chips here. And then, of course, added a connector here on the output and added a connector on the input right here. And let me show you. These are the two connectors. The input is here, the output is here. And if you want to see what the connector looks like when it's not installed, this is one. But you take an X-Acto knife and you cut off the Teflon here, flush with the flange. Remove all the Teflon on the pin. And this will allow the whole connector to sit flush, and the hole will be just large enough to fit the center pin through the board. And I also made sure, before I install the connectors, I made sure that the ground plane, this is the ground plane on the whole bottom side, made sure that it cleared the hole that I drilled so that the center pin is not shorted to the ground plane. Just enough, you know, just enough. Same thing for here. And this is a 7806 regulator, 6-volt regulator, which I also recovered from the board here. I didn't have any 7806. I had a lot of 7808s and 7805s, but no 7806. So I said, well, let's recover it. Heat gun, recovered. It's surface mount, so I lifted the two pins, input and output, and connected up directly to the pins, out, going to a decoupling cap to ground, and this goes to the chip, the biasing chip. And this is the input here, coming into the input pin of the regulator, and there's a 1 microfarad decoupling on the input. And I soldered the tap directly to the ground plane. So that's how I created my preamp. And performance is 24 dB of gain. And the noise figure, the transistor is typical noise figure 0.3 dB. But between you and me, it's certainly less than 1 dB. But there's a bit of attenuation here through the connector, through the board. So it's probably something around 0.5 dB of noise figure, which is very good at 10 gigahertz. And one thing I have to tell you, I blew up that transistor, the first stage. So luckily, I had the board on the other channel available, recovered the transistor for the input, and soldered it back in place here. Why did I blow it up? Because the input is a FET, very fragile, very, very fragile. And I had the ground here still connected to my power supply, but the power supply is a floating power supply. And when I came in with the soldering iron to touch up the input connector, I guess it must have sent a pretty large voltage through the gate and it blew it up. But since I had another one, a spare from the other channel here, fine. Hot air again to remove the old one, and then solder the 4 pins with everything always floating, nothing connected on the preamp board. And I even use the tip of the soldering iron. I touch the ground first with the tip before I go to rework, just to discharge any static electricity, even though the soldering iron is tip grounded. So don't know why it blew up, but it did. Anyway, that's the result. The only thing left now is to put it in a sort of enclosure. I'm not sure exactly what type of enclosure I'm going to use. This is pretty small, as you can see. Not even as wide as 3 fingers. So it's much, much smaller than the previous project I built. And now I'll find an enclosure. Probably I'll design it custom made to fit that thing. All right, all for now. On to the next stage, 7.3.